Here are a few more inverse trig functions that we can work on for extra practice. And I want to find the antiderivative for these next few problems here. Over here on the right hand side, I do have a few more inverse trig antiderivatives that we haven't used yet. So let's apply them to the next questions in this video guide. All right, so for the very first question here, I noticed that there's a 16 in the denominator inside the square root. So I can definitely rewrite this as 1 over the square root of, now instead of writing 16, I can write that as 4 squared minus x squared times dx. And now this kind of looks very similar to the formula here on the right hand side, because now the a value is going to be 4. So if I want to go ahead and just follow the formula here, it would be the inverse of sine x divided by a, and the value of a was 4, so x divided by 4, and then plus c. And that's it. That's all you have to do for that particular question. You just have to recognize that the problem is leaning more towards an inverse trig function because it's set up very similar to one of your identities. Okay, let's move on to the next question here. All right, so this is another question where we can, but just by looking at this, it's probably going to look like one of our inverse trig functions here. So I want to find the antiderivative here. One thing that you may want to do is you can take this 2 and you can move it to the front. So the 2 can move to the front, then integral sign, and then 1 over the square root. And now there is a 9 there, so I can replace the 9 with 3 to the power of 2 minus x squared times dx. And just like the previous problem, if I line up the 3 with the formula here, the a value here is going to be 3. So I can just jump to my antiderivative now. The answer should be 2 times inverse of sine minus 1, x divided by 3, and then plus c. And that's it. That one's a quick one. Okay, let's move on to a question where I have to use an inverse tan of 1. This one's slightly different because I have x squared and a squared on the denominator, and therefore the formula is going to have a 1 over a in front. So if I take a look at this 4 here, I can rewrite that as 1 over 2 squared plus x squared, and then the integral sign, and then dx. And if I just highlight the 2 here, this 2 will now represent the a. Sorry, that didn't really come out very nicely here. This 2 here will represent that a. So my answer will be 1 over a, which is 1 over 2, inverse of tan minus 1, x over 2, and then plus c. And that's your final answer for that one. Okay, let's move on to question number 4. All right, so for question number 4, a little bit of work here. Let's start off with the 3 here. Let's just move that to the outside here. So it'll be 3 times the inverse, the antiderivative of 1 over. Now this 3, I can represent the 3 as 3 to the power of 2 plus x squared times dx. Okay, and then lining up this 3 with this a value there, I can write this as 1 over a, so that's going to be 1 over 3 inverse of tan minus 1 x over 3 plus c. And then we still have this 3 that's tagging along over here. So the 3 and the 1/3, they can just cancel off. So your final answer will be inverse of tan, x over 3, and then plus c. And that should do it for that question there. Okay, so let's move on to, I think those ones were pretty straightforward. Let's go over some questions where we do slightly a little bit more work. So for this particular question here, I have the integral of 2x divided by the square root of 9 minus x squared. So this question, I had to do a little bit of work for this particular problem, and this is going to be a U-substitution question here because there's an x variable on the numerator there. So I'm going to let my u be the denominator, or the expression inside the square root. So let's just say u equals to 9 minus x squared. Okay, and if I do that, I will rewrite this as the integral of 1 over the square root of u, and then this 2x right here and the dx, I'll put that together as a team here. So 2x times dx there on the right hand side. And then let's go ahead and find the derivative over here. So du over dx, this is going to be negative 2x. And that's looking pretty good because I see a 2x over here. So then I can just rearrange this to be du equals to 2x times dx. And then with this minus sign here, I can just move that over here. Okay, and now I can see that the 2x here matches up exactly with that, and now I can do a u substitution there. So this is the integral of 1 over the square root of u times negative du. And if I do just a little bit more work here, I can move the minus 1 to the front. And if I do that, that's going to be a minus sign there. The integral of, now this part right here in the inside, I can write that as u to the power negative 1/2 times du. And then now I've kind of written up the problem in a way where I can just take the antiderivative normally. So I need to add a 1 to the power. So if I add a 1, that's the same thing as adding 2 over 2. So u to the power of 1/2 divided by 1/2 plus c, and then I have this minus sign that's just tagging along over there. Okay, that's a little bit of work there. Let's just go ahead and clean this up now. This 1/2, if I just multiply it with the negative sign, that's going to be negative 2 square root of u plus c. And remember, what was u again? U was, at the start of this problem, we allowed u to be 9 minus x squared. All right, so this will be negative 2 square root of 9 minus x squared plus c, and there you go. So that kind of question right there was basically a u substitution question. It looked very similar to an inverse trig question, but it just turned out that we just used regular u substitution. Okay, let's take a look at the very last question for this video homework guide. And for this question, I'll be using a combination of u substitution as well as one of the inverse trig identities to finish the problem off. Now for this particular problem here, I'm going to take a look at the numerator here, this 2x minus 1, and I'm going to split that up. So this is, I'll leave that as 2x and then a minus 1 over here. And then I will divide everything by the denominator, which is x squared plus 4. So this is going to be x squared plus 4, and this is also going to be x squared plus 4. Sorry, my pen's just not working here. Okay, and then I can write my integral sign. So the integral of that times dx. Then this minus sign, I'll just move a little bit to the middle here, and then the integral sign, and then dx. Okay, so now I'm in pretty good shape now to start working on this problem here. Let me start off with the right-hand side of this problem right here, because I can line this up with this little formula right up here. Because we know that this 4 right here, that's the same thing as 2 to the power 2. So that means a has the value of 2. So this will be minus 1 over a, which is 1 over 2, inverse of tan, minus 1, x over 2, and then plus c. So that is the right-hand side of the problem there. We just use the inverse trig formula there. Now, however, the question here on the on the left-hand side, this green box right here, for that particular problem, we do have to use u substitution. So I'll let u be equal to x squared plus 4. Now, if I do that, the integral will now look like this. The integral of 1 over u, and then this part right here in orange, the 2x and the dx, I'll just move that to the side here, 2x dx. And if I continue to take the derivative of this blue box right here, let me just pull that to the side here. I know this is kind of messy here, but I'll try my very best to finish it up. If I take the derivative here, this is going to be 2x, and then I can simply take the dx and move it to the top right-hand corner there. So this will be du equals to 2x times dx. And as you can see, the 2x dx matches up with that. So I can now write this as the integral of 1 over u times du. And the antiderivative of this expression right here, this one's a quick one. That's just going to be ln absolute value of u plus c. And now remember, u was this x squared plus 4. So if I finish this off, this will be ln of absolute value of x squared plus 4. And after that, I can take this expression here in purple and just tag along at the very end here, minus 1/2 tan inverse 1 x over 2 plus c. And that would be my final answer for that particular question. So yeah, there's a few good questions here where you can practice some additional inverse trig function questions and some more U-substitution. And that should be it for this video homework guide.